India's space program has built some of the most impressive rockets on the planet. I mean, these things can reach for the farthest corners of our solar system. But there's a catch. Right here in our own cosmic backyard, an invisible danger is brewing, and it's putting every single one of these incredible missions on a potential collision course.
Just look at this thing. It's a symbol of incredible power, right? Pure ambition. But what if I told you the biggest threat to its mission isn't some complex engine failure, but a tiny little piece of junk, maybe the size of a marble, screaming through space at 17,000 miles per hour? That is the unseen battlefield we're diving into today. So, what makes these Indian rockets so special, and what makes them so incredibly vulnerable?
Okay, so first things first. To really get a handle on the risk, you need to meet the two main players, the real pillars of India's launch program, the GSLV and the PSLV. All right, let's start with the GSLV, the Geosynchronous Satellite Launch Vehicle. The best way to think about this one, it's the heavy-duty long-haul truck of India's space fleet. Its entire job is to hoist these enormous, really expensive satellites, we're talking the ones that power our communication, our navigation, way, way up. It takes them to what's called geosynchronous orbit, a whopping 36,000 kilometers above us. And what's so special about that spot? Well, up there, a satellite orbits at the exact same speed the Earth spins, so it just kind of hangs there, motionless, over one spot on the globe, perfect for beaming down signals 24/7.
And you can just feel the raw power in a launch like this. I mean, to get a payload that heavy, to an altitude that extreme, it takes a truly massive push. That's why the GSLV relies on a super advanced cryogenic engine. We're talking super-cooled liquid fuels that generate just immense, incredible thrust. This thing is a true heavy lifter, no question about it.
Okay, now let's meet its sibling, the PSLV, or the Polar Satellite Launch Vehicle. If the GSLV is that big, heavy-duty truck, the PSLV is the reliable, everyday workhorse. You could almost call it the pickup truck of the fleet. This is ISRO's go-to rocket, the one they use most often. Why? Because it's famously dependable and super cost-effective. It doesn't go nearly as far, though. It operates much closer to home in what we call low Earth orbit, or LEO. That's a super busy area just a few hundred kilometers up, perfect for dropping off satellites that do things like watch our planet, sense changes in the environment, and monitor the weather.
So this really lays it all out, doesn't it? On one hand, you've got the GSLV, the long-haul specialist for those huge satellites way out in a fixed orbit. And on the other, you have the PSLV, the versatile workhorse, constantly zipping through those crowded lower orbits. And you know what? This difference, where they fly, that is absolutely critical to the danger we're talking about.
So, we've met our two heroes, right? The heavy lifter and the workhorse. Now, it's time to meet the villain. And this villain, it doesn't have a face, it doesn't have a motive. It's a concept, a chilling idea called the Kessler Syndrome. And it's single-handedly turning our orbital highways into an invisible minefield.
The basic idea is actually pretty simple, but it is absolutely terrifying. See, space is getting crowded, really crowded. The Kessler Syndrome describes a tipping point, a point where there's so much junk orbiting Earth, old satellites, discarded rocket parts, little fragments from past collisions, that a single crash can set off a devastating, unstoppable chain reaction.
So let me walk you through how this nightmare scenario unfolds. It all starts with just one collision. Two objects hit, bam. They shatter into hundreds, maybe thousands of smaller pieces. Now, these new fragments are like shrapnel, and they're all moving at insane speeds. They spread out and they start hitting other satellites, which creates even more debris. It's a vicious feedback loop, and the scary part is, once it really gets going, it might be impossible to stop. And this visual shows you the stark reality of what we're dealing with. This is not some sci-fi movie concept. This is not a future problem. This is a map of the junk orbiting our planet right now. Every single one of those little white dots is a potential bullet in a massive game of cosmic Russian roulette, and it's threatening every single launch.
And believe me, the stakes here are incredibly high for every single one of us. Just think about your daily life, the GPS that gets you from A to B, the weather forecast on your phone, heck, even global banking and the internet itself, all of it depends on this fragile network of satellites operating safely. If these orbital highways become too dangerous to use, the modern world as we know it could literally grind to a halt.
Okay, so we've got our rockets, we've got our threat. Let's connect the dots. Let's see exactly how this orbital collision course puts India's space program right in the crosshairs. So yeah, how does this invisible threat actually affect these rockets? It's a great question, right? Because you've got one rocket flying way up high and the other flying down low. You'd think the risk would be totally different for each of them. And, well, you'd be right, but probably not in the way you're thinking.
Let's talk about the PSLV first, the workhorse. For this rocket, the danger is direct. It's in your face and it's constant. Remember, it operates right in the thick of low Earth orbit. That is the most congested, most debris-choked region around our entire planet. So every single satellite it launches is delivered straight into the heart of the danger zone, where it has to dodge bullets for its entire lifespan.
Okay, but what about the GSLV, our heavy lifter that's heading way up high? You'd think it's safe, right? Well, here's the thing. It might be going to a much quieter neighborhood, but to get there, it has to drive right through the most dangerous part of town. It has to fly through that cluttered, chaotic mess of low Earth orbit. And that means during that critical ascent phase, this massive rocket, carrying this unbelievably expensive satellite, it's a sitting duck. One unlucky hit from a tiny piece of debris and the entire mission is gone. Just like that.
And really, that's the key takeaway here. It doesn't matter if you're launching into low orbit or high orbit. This isn't some localized issue. The Kessler syndrome is a threat to the entire space ecosystem. Every launch, every satellite from every single nation is at risk.
All right, so if scientists have known this was a possibility for a while now, why the sudden urgency? Why are all the alarm bells ringing now? What's changed that makes this feel like a ticking clock?
It's because the problem has officially moved out of the realm of theory and into reality. I mean, for decades, the Kessler syndrome was this distant, almost academic concept, something our kids or grandkids would have to worry about. But the latest data shows the density of debris has hit a critical level. The tipping point isn't some far-off possibility anymore. It's a clear and present danger.
And this urgency is being driven by a perfect storm of factors, all happening at once. First, we're seeing a massive spike in debris density, especially down in Leo. At the exact same time, we're launching these huge mega-constellations with thousands of new satellites, jamming the orbital highways like never before. And all the while, decades worth of our old junk, dead satellites, spent rocket parts, is still up there circling. What's the result? Well, some regions of space are now frighteningly close to that critical density, the point where a chain reaction goes from being just possible to being probable.
And the consequences of that? They're just staggering. This isn't a mess we can just decide to clean up next year. If one of these cascading collision events kicks off, experts are warning that entire orbital highways could become totally unusable for decades. Think about that. An entire generation, maybe more, could be locked out of space, trapped on Earth by our own trash. Which really leaves us with one final, sobering question. Every rocket we launch, from the GSLV to the PSLV, is supposed to be a gateway to the stars, a step forward for humanity. But if we don't get this right, and get it right soon, are we actually building a trap we can't escape? Are we forging the bars of our own orbital prison, one that could cut us off from the universe for a very, very long time?